Accepting that you put it where the sun is, it would loosen up to the circle of Jupiter. It's huge, genuinely shaky, and going to explode. These impacts are among the best blasts of radio energy in the entire universe, making more energy than a billion suns. Are you set up for what will happen? Bug crush, a gigantic red supergiant star, and one of the closest stars to Earth, has as of late gone through a vital obscuring that has gotten attention and stirred sentiments all over the planet. This obscuring has led to speculation among cosmologists and the public about its possible implications. Some scientists believe this amazing behavior could be a forerunner to a cosmic blast, a catastrophic event that occurs when a star exhausts its nuclear fuel and collapses under its own weight, leading to a massive explosion. Such an event raises concerns not just among standard scientists, but also among the general public, as it prompts questions about the possible impact on our own planet. Scarab Juice is a notable star grouping that is easily recognizable in the night sky due to its distinctive shape and bright stars. Also referred to as Alpha Orionis, it holds the title of the brightest and largest star in this constellation. Recent data collected by NASA's Hubble Space Telescope, along with observations from other observatories, have shown that Scarab Juice experienced a significant mass ejection in 2019. This behavior is unusual for a star of its kind and has sparked interest among astronomers worldwide. While coronal mass ejections are a common occurrence in our own sun, the exceptional event observed in Scarab Juice adds a fascinating layer to our understanding of stellar life cycles and the dynamics of massive stars. The distance to Scarab Juice remains a topic of debate among astronomers. Some estimates suggest it is farther away, while others indicate it could be as close as 724 light-years from Earth. Precisely determining the distances of red supergiant stars, like Scarab Juice, is a complicated challenge due to their immense size and unique properties. Scarab Juice stands out as one of the brightest stars visible in our night sky, boasting a luminosity many times greater than that of the sun. However, this tremendous brightness comes at a huge cost. Scarab Juice burns its nuclear fuel at an accelerated rate, hastening the inevitable end of its stellar life. Eventually, the star will exhaust its fuel supply, leading to a dramatic collapse under its own gravitational pull, potentially resulting in a cosmic explosion that could give birth to a neutron star, or even a black hole, if our current astrophysical theories prove correct. This raises a significant question. Does Scarab Juice pose a threat to Earth? If a massive explosion were to occur just a few hundred light-years away from our planet, the consequences could be devastating. The impact of a supernova can release an extraordinary amount of light, potentially equaling that of an entire galaxy. Therefore, even if Scarab Juice is relatively far away, like the star Alpha Centauri, the effects of its cosmic explosion could be significant and far-reaching. Remarkably, since the last astronomical explosion witnessed in our own galaxy in 1604, humanity has yet to observe such an event locally. However, a notable cosmic explosion occurred in 1987 in the Large Magellanic Cloud, located 169,000 light-years away. While that event had significant impacts, it posed no direct threat to Earth, serving as a reminder of the scale and potential effects of such cosmic phenomena. The concept of a danger zone surrounding a typical cosmic explosion is intriguing and could have serious implications for life on Earth if a supernova were to occur nearby. However, it's important to understand that in the vast galactic landscape, nearby supernovae are relatively small events compared to gamma-ray bursts, which are far more powerful and pose a different kind of threat. Gamma-ray bursts can have devastating effects, capable of destroying biospheres and saturating planets with lethal radiation. For instance, a particular type of cosmic explosion can lead to the destruction of a planet's ozone layer, leaving it vulnerable to the harsh radiation of space long after the impact has occurred. This potential was highlighted in a recent study that outlined new potential dangers associated with massive stars that end their lives in such a spectacular way. When massive stars explode in a supernova, they can reach some of the brightest luminosities known in the universe. In fact, the brightness of a single supernova can surpass the combined brightness of billions of stars. This raises the question of what the consequences would be if Scarab Juice were to undergo such an explosion. If a supernova were to occur, Scarab Juice would become the second most brilliant article in our sky after the sun. Astoundingly, notwithstanding the distance isolating it from us. Bug juice, which sparkles more brilliantly than a full moon, would become apparent during sunlight hours. The sheer power of the blast would bring about a showcase so staggering that shadows would be projected even in complete dimness. Such a scene would be both awe-inspiring and unnerving, showing the crude force of inestimable events. While the visible light produced by a supernova is indeed staggering, it is only a small part of the total energy released during such an event. Although elevated levels of visible light can cause temporary visual impairment, the greater concern lies in the high-energy radiation emitted alongside the visible light. This radiation often appears as X-rays and gamma rays, which can have extensive consequences. One of the main dangers posed by this high-energy radiation is its ability to catalyze the depletion of the ozone layer that protects our planet from harmful solar radiation. Without a robust ozone layer, life on Earth's surface would be exposed to extreme ultraviolet radiation from the sun, potentially leading to mass extinction events. The immediate aftermath of a supernova presents imminent risks, but over the long term, cosmic rays and subatomic particles traveling at near-light speeds begin to invade the solar system. These cosmic rays can break down ozone layers and coat the Earth's surface with harmful radiation, compounding the dangers posed by the initial blast. Moreover, these cosmic rays carry a significant portion of the total energy released by the supernova, and their long-term effects could linger for thousands of years. There is evidence suggesting that such events might have influenced Earth in the past. For instance, elevated levels of iron-60, a radioactive isotope produced in supernovae, have been found in seafloor sediment and lunar regolith. This finding suggests that Earth may have been affected by supernova ejecta in relatively recent geological history, perhaps within the last few million years. Astronomers have previously deduced that there are currently no nearby supernova candidates that pose an immediate threat to life on Earth, based on what we know about the risks associated with gamma rays and cosmic rays. However, ongoing research has revealed new potential dangers associated with specific types of gamma ray bursts. These gamma ray bursts can produce long-range lethal radiation that poses a more serious risk to planets like our own. The mechanism behind this involves a star nearing the end of its life, being surrounded by a significant disk of material. When the supernova occurs, a shock wave is generated, striking this disk and causing it to become extremely hot. This, in turn, produces large amounts of high-energy X-ray radiation, which can travel enormous distances through space. The most brilliant X-ray supernovae have the potential to deplete a planet's ozone layer by as much as 50%, creating conditions that could trigger an extinction event within a radius of around 150 light-years. Fortunately, no candidate supernovae have been identified in the immediate vicinity of Earth. However, this research has led to new insights regarding the cosmic habitable zone, the area within galaxies where conditions are suitable for life. These findings suggest that this habitable zone may be subject to additional restrictions. Specifically, the outer regions of a galaxy may not have enough star formation activity to generate the elements necessary for the formation of rocky planets. Meanwhile, the inner regions, where stars form and die at a faster rate, pose their own risks. Frequent supernova blasts in these regions can light up the surrounding space, increasing the risks for any potential life that might exist there. Recently, the reshaping of our comprehension of where life may, in reality, flourish has been more profound than previously suspected. So, what will the bug-juiced cosmic explosion look like from Earth? While Earth's biospheres will probably stay unaffected, the actual exhibition will be difficult to overlook. According to specialists, bug juice will continue to shine brightly for over 90 days following its blast, reaching a radiance equivalent to a portion of that of the moon, though a few times fainter than a full moon. Essentially, it will appear as a brilliant point overhead, visible even during the day. Its striking splendor will dazzle anyone who looks up, creating shadows even at night. This amazing heavenly event will undoubtedly be a wellspring of interest for people on Earth, as the cosmic explosion remains visible to the naked eye for months. Its remnants will gradually fade, but researchers will continue studying bug juice to learn more about the life cycle of massive stars and the processes that lead to their violent ends. Understanding these enormous phenomena is essential for gaining insights into the evolution of our galaxy and the formation of elements during a cosmic explosion. Not only is visible light produced, but a large range of heavy elements like gold, silver, and uranium are forged in the intense heat and pressure of the blast. This process, known as nucleosynthesis, plays a critical role in enriching the interstellar medium with the building blocks necessary for future star and planet formation. Interestingly, the remnants of a cosmic explosion, known as a supernova remnant, can become a stellar nursery where new stars are born from the dust and gas expelled during the blast. This recurring process highlights the interconnectedness of cosmic events and how the death of one star can lead to the birth of others. Researchers have identified various supernova remnants that are still forming new stars long after the original explosion, showing the dynamic nature of the universe. Another fascinating aspect of studying supernovae is their role as cosmic distance markers. Astronomers use Type Ia supernovae, the explosions of white dwarf stars that reach a consistent peak brightness, as standard candles for measuring distances in the universe. This technique has significantly contributed to our understanding of cosmic expansion and the discovery of dark energy, a mysterious force driving the acceleration of the universe's growth. Moreover, the study of supernovae offers insights into the potential habitability of exoplanets. Scientists are examining how the radiation emitted during these stellar explosions could affect planets orbiting nearby stars, potentially influencing their atmospheres and the viability of life. This research underscores the importance of understanding the environmental conditions that govern life across the universe. The possibility of observing a nearby cosmic explosion raises intriguing questions about how society might respond to such grandiose events. Throughout history, supernovae have inspired myths, legends, and creative expressions. The explosion of a star is not just a scientific phenomenon. It becomes a powerful symbol in human culture, representing change, destruction, and rebirth. In many societies, the appearance of bright new stars in the night sky has been interpreted as signs or messages from the universe. Furthermore, advances in technology have revolutionized our ability to detect and study supernovae. Space telescopes equipped with cutting-edge sensors can capture detailed images and spectra of these events, revealing their structure and behavior. Ground-based observatories also play a critical role in monitoring transient events, allowing astronomers to respond quickly to observations and gather real-time data. The future of supernova research holds exciting prospects, as new telescopes and instruments like the James Webb Space Telescope promise to offer unprecedented insights into the life cycles of stars and the dynamics of their catastrophic deaths. These observations could lead to breakthroughs in our understanding of stellar evolution and the fundamental processes that shape our universe. In summary, the study of bug juice and its impending cosmic explosion serves as a gateway to broader discussions about cosmic evolution, universal recycling, and the impact of these phenomena on life and culture. The examination of such massive stars deepens our appreciation for the complex and often violent processes that govern the universe, illuminating our place within this vast, ever-changing cosmos. Supernovae also play a crucial role in the larger cosmic timeline, marking the end of a star's life and the subsequent formation of new celestial structures. For example, the remnants left behind can evolve into nebulae, vast clouds of gas and dust that act as fertile ground for new star formation. These regions can harbor complex chemistry, contributing to the development of organic molecules that are the precursors to life. Additionally, the shock waves generated by supernova blasts can trigger star formation in nearby molecular clouds. This process, known as triggered star formation, demonstrates the interconnectedness of cosmic phenomena and shows how a single explosive event can set off the birth of new stars and planetary systems. This highlights the significance of supernovae, not only as endpoints but also as catalysts for future galactic evolution. In the grand scheme of the universe, supernovae also contribute to the dispersal of heavy elements throughout the cosmos, enriching the material from which future stars and planets are formed, and ultimately influencing the chemical diversity essential for life. This cosmic recycling underscores the importance of understanding supernovae in the broader context of cosmology and the origins of the elements that make up our own planet and life itself.